Hello and good day everyone. So we'll start with our first tutorial, which is on the chapter concept of function, chapter 1. So let's go straight to question 1. Question 1 gives you a text, as you can see right now. I'm not going to read everything, please read it carefully first. And we are asked to formulate the function LT, which is LT is actually it asks us to find the labor cost of year N, where LT equal to initial labor cost of year T, and T is the year, of course. Now let's start. Okay. Question 1. So, year 1, I'll label it as year 1. So, it will be L1, right? Instead of LT, since this is year 1, T is equal to 1. L1 is equal to L0 minus 0.05 times L0. Why is this? Because in the question it says that the labor cost fall by 5% for the first year, right? For the first year, which means it drops by 5% from the year before. So during the first year, the year before is year 0, so L0. So the initial L0 minus 5% of L0, you will have your L1, the labor cost for year 1. Right, clear? So in simple words, in the first year, the labor cost dropped by 5% compared to the initial labor cost. So initial labor cost is L0. So drops by 5%, which means 0 minus 0.05, which is 5 over 100 times the initial labor cost. So this is your labor cost for year 0. So let's see for if it is the second year, year 2, it says the cost continue to fall with a double effect from the year before. It means double effect. The first year, the drop is 0.05, but the consequent years will be 5% than the previous years. Okay, can you see? So, labor cost for year 2 is equal to labor cost for year 1, the year before, minus double the effect of 5% time 1. Okay, can you see? Basically the same question, but it is double the effect, right? So this is second year. Now for year N, this one you need to think by yourself. Year N, so Ln is equal to, so Ln is the year we want to find, so it will be the previous year, which means Ln minus 1, right? Minus, now what is this? What should we put here? Inside it will be the same like this, 0.05 times L times Ln minus 1, right? So here you cannot put 2 because each subsequent years is increased by 2, which means 1, 2, 4, 8, right? 1, 2, 4, 8, 16, double, right? So how do you formulate that? It is actually 2 times 2 to the power of n. Is it minus? Sorry. Yes, I believe it's minus 1. Right? Try. You need to remember this. Not remember. You can actually find it by yourself, but there's no quick way on how you can get this. You need to think. Okay, just to show you what I made. Right? I'm sorry. I saw, and there's no 2 here, so it will be just 2 to the power of n minus 1. Okay, sorry. So let's test. 2 to the power of x, 2 to the power of x minus 1. If you plug in 1, x equal to 1 will be 1, x equal to 2 will be 2, x equal to 3 will be 4, x equal to 4 will be 8. So it is double each time. 1, 2, 4, 8, 16 and so on. So this is your equation, but you need to indicate where n equal to 1, 2, 3 and so on. Okay, so this will be your answer for question 1. Now let's move to question 2. Question 2 asks you to represent the number of days for the months in a leap year in the form of arrow diagram. I believe it is easier just to show you the result because this is just very straightforward. Now let's look at the answer. Okay. Now this is the answer. So x is the months and y is the number of days in a month. So this is a leap year. You will have 29, 30 and 31, and only February will be matched to 29, and others you just match it yourself. And I just realized that there's no December here. Please add December and down here. Okay, this is pretty straightforward. Let us move to question 3. Question 3 asks us, gives us the incomplete information for the voltage based on the Ohm's law. V equal to IR is given in table 1. Display the relation between V and I using the graph representation. So now we are given, so this should be question 3 instead. We are given I, which is in ampere, and R, which is in ohm. 1.3, 5 ohm, 0.8 is 7, 0.6 is 8.5. But it asks us to display the relation between V and I using the graph representation. So basically you need to find V, which is in volt. How do you find V? V is equal to I times R. So this time this, you'll get this, the same here and here. So you'll have 6.5, 5.6 and 5.1. Now the only thing you need to do is draw the graph of V against I. So V will be the y-axis, I will be the x-axis. So your graph will look like this. Okay, pretty straightforward as well. Now let's move on to question 4. Question 4 gives us, again, just like question 1, in words. The question is in words. I'll just read it because it is easier. In box manufacturing industry, two main assembly lines are the conveyor line and box assembly line. A number of workers are placed in the first line. The number of workers allocated in the second line is half the number of those placed in the first line. The assembly lines run into 8-hour shifts on daily basis. The industry is hiring its first and second assembly line workers on daily labor charges of RM23 per hour and RM19 per hour respectively. Represent the total labor cost the industry spent on both assembly lines per day in mathematical function for the event if 1 to 5 workers are allocated in the first line. So, assembly lines run in 2 8-hour shifts on daily basis. And the number of workers allocated in the second line is half of the number of workers allocated in the first line. And the labor charge for those in the first assembly line is RM23 per hour, and for those in the second line is 19 per hour. We need to represent the total labor cost the industry spent on both assembly lines per day in mathematical function for the event if 1 to 5 workers are allocated in the first line. So, what you need to do is analyze the conditions given. Now, and just let x equal to number of workers in first assembly line and as x equal to total labor cost. So we'll need to find Sx, right? So total labor cost is equal to the number of workers in first assembly line, which is x, times 16. Did you know why 16? Because it says that 2 8-hour shifts, right? So 2 8-hour shifts means 16 hours in total, and times the cost for the workers on the first line, which is 23 ringgit, plus the number of labor in the second line, which is half of the number of labor of the first assembly line, which is x, times 16 as well, 16 hours, and the cost for labors in the second assembly line, which is RM19. Now this is basically your equation, but it asks you for the event if 1 to 5 workers are allocated in the first line. So what you need to do is just plug in 1 and find your answer. Find S1, S2 until S5, right? That's how you do it. Now let's move on to question 5. Question 5 asks us to determine whether the following given equations are one-to-one function. The first equation is fx equal to 11 x squared minus 1331. If you recall from your lecture, to determine whether a function is one-to-one, of course you can draw the graph one of the way, but if you don't want to draw the graph, you need to equate this equation to this equation, but replace x with s1 and the other side is s2. So what you can do is 11 x1 squared minus 1331 equal to 11x2 squared minus 1331. Okay, so you need to solve this and see whether x1 is equal to x2. And when you solve this, you will find that x1 is basically equal to x2. I hope you know everything will cancel out each other, right? And because of the square root, the square is also removed, so there's no plus minus, right? So x1 is equal to x2, which means it is 1-to-1 function, but there's a condition. At what? We need to find at what, and how do you find it? Because there's a surd, right? It cannot be function for the whole region, because when you have surd, there's a condition where the inner part of the surd must be more than 0, right? It cannot be negative inside because it gives you no answer. So 11 x squared minus 1331 must be more or equal than 0. So you solve this, you'll get x more or equal than 11. So this is a 1-to-1 function at x more or equal than 11. So this is your answer. Okay, now let us see question 5 part B. The function is gx equal to 3/2 x squared minus 7. Now let's see, we do the same thing, we equate both sides. X1 squared minus 7 equal to 3/2 x2 squared minus 7, right? And you will get, is x1, when x1 squared is equal to x2 squared, does it mean x1 is equal to x2? No, right? Because if you remove the 2, it will be plus and minus, right? Just like this one, but this one it has surd, so it cancels the square. So one way where you can prove this is by trial and error. Let's see, if we put if x1 equal to x2 equal to 1, we'll get, if this is 1, this is 1, you'll get x1 equal to x2, right? So you see, this is a function, right? But what if x1 equal to -1 and x2 equal to -1, x2 equal to +1, you still get 1 equal to 1, right? It will be -1. This one will be 1 squared equal to 1 squared. So 1 equal to 1. And here, the same thing, -1 squared equal to 1 squared, it will be 1 equal to 1. So 1 is equal to 1, but x1 is not equal to x2, right? Right? This is negatively positive, so it is not 1-to-1 function. Okay, now let us proceed with question 6. Question 6 asks us to determine whether the following are many-to-one function. Okay, many-to-one function. So the first equation is fx equal to 11. So this is a very simple. Personally, I prefer drawing the given function so that it is easier for us to see. So this is a very simple function. If the function is simple, you can draw easily, right? This is y, x, this is fx equal to 11, right? So when you, it is of course a function because it intersects and the y-axis only once, right? But whether it is many to one, you need to do the horizontal line test, right? So a horizontal line test will give you many values, right? At x equal to 1, at y equal to 11, there's a lot value of x, right? So this is many to 1. What about b? Gx equal to x power of 4 minus 18. So when you draw this, we'll have something like this. If you don't know how to draw, you can just plug in your calculator, right? Just use your calculator, put in unknown x to the power of 4 minus 18, and you plug in values from negative something. You just try negative 5 is too big, then you scale down the numbers, maybe from then negative 0.9, and you try to do it and you plot like x, then you just connect everything together. You just want the shape, right? You don't need a very accurate plot. So that is one way how you can do it. So this, when horizontal line test will give you two intersections. So it is also many to 1. Correct? What about part C? Part C gives you a graph. So I'll show you just the solution. So this is the given graph. This is the given graph. And you can see that down here, there are, if you draw a horizontal line at the origin, you have many intersections in the middle here where the values of x are the same. So it is also many to 1. Okay, let's proceed with question 7. So determine whether the following function is onto. So how do you determine whether a function is onto? Let me write first question 7, and part A is So how do you determine an onto function? You can determine an onto function if for a function, for example fx, so for every value of fx there must be a value of x. Okay, so let's see the first one. Fx equal to negative kx, where k equal to 100.8 n over n for all real numbers. So if you draw the graph, you'll have something like this. Okay, you'll have something like this. Now, does every value of fs is there always be the value of x? Yes, right? For every fx there is the corresponding value of x. So this is onto, right? This is to negative infinity, this is to infinity, right? So this is a linear line, of course it is onto. Now let's look at part B. Gx equal to x minus 64. This is very easy to draw. You can even use the method that I taught you before if you all have trouble. So this graph will look like this. Now, is this onto? Is this onto or not? So you see that basically in general this is not onto, right? Because at negative value of gx there is no value of x, right? So but you can also answer this in terms of words. You can also say that this is onto only if g x all real number and y not y, yes, y only positive real number. Okay, like this, which means that it's onto only when y is positive, right? But in general it is not onto, because at negative of gx there's no x. Now let's proceed with question 8. Question 8 is very straightforward as well. Question 8. A standard equation called the scale height is often used in meteorological studies to estimate atmospheric pressure as a function of altitude. The scale height equation is given by. So basically the given equation is so you are given this equation and all the values, and you just need to plug in. First you plug in all the values, you'll get pH equal to 1.01 times 10 to the power of 5, E negative 0.13 0.1312-ish. So determine if the relation shows an onto function. Basically the same question as before. Just draw and determine whether it is onto. So when you draw, you'll get something like this. You get something like this. So is this onto? In general it is not onto, right? Because at negative y there's no value of x, just like this one. So you can answer like that, or you can also answer like this. Okay, onto only if g x are positive, y are positive, y x is also are positive because there's no value, negative value of x as well, right? Here there's negative value of x, right? If you go beyond this is to negative infinity, we'll have negative x, but this will never have negative value of x. Okay, that's it for question 8. Let's continue with question 9. So question 9 asks us to determine whether the given functions are function or the given equations are function or non-function. So fx, the first one is fx x minus 7 squared. Okay, is it a function? How do you determine a function? You can determine a function by doing the vertical line test, then the horizontal line test, right? So it's easier if you draw. This is indeed easy to draw. So if you draw this, you'll have something like, even if you saw it, even if you see the equation, you'll know that the shape is somewhat like this, right? So horizontal line test will give you one intersection, and vertical line test. So horizontal line test will give you more than one intersection. So this is a many to one function. Okay, now let's see part B. Part B, we have x equal to fx minus 7 squared. So fx is here, so you draw similarly, but the graph will be also inverted since x is the subject here. So you have something like this. Try yourself. So vertical line test have more than one intersection, so it is already not a function. So you don't need to do the horizontal line test, just the vertical line test. So this is not a function. Okay. Now question 10. Question 10 asks us to identify whether the given figures are continuous or not. So question 10. So figure 1 and figure 2. So is figure 1 is not continuous, right? Or discontinuous? Because there are it is not connected at the whole domain, right? There are gaps between the lines. But figure 2 is, of course, continuous. Okay, that's simple enough. Now let us move to question 11. We're given a function which is sin x over x plus 1, and we are asked to find a limit x approach 0 from the left fx. Okay, so basically I don't know any quick way or any guided way how we can solve this. Even in the textbook doesn't gives you anything on how to solve from the left and from the right, unless you draw the graph. If you don't want to draw the graph, what I did last time was just plug in the function in your calculator where x is the unknown, and then you plug in numbers reaching 0 from the left. So 0 from the left will be, let's start with, don't put extreme values like -10, right? Because the graph might not shape symmetrically, they might have curves, so don't put any extreme values, or you might have different perception of how the limit is. Okay, now let's put -1 first. -1, you cannot put -1. Why? Because -1 plus 1 is 0, right? So cancel -1, plug in negative. What is after -1? I'll try -0.9. I get -7.83. Then we'll try -0.7. -2.4 is smaller, right? Even smaller. Negative, we are reaching 0, right? So smaller number that is reaching 0, I'll try 0.3. Okay, the value is getting smaller. Try negative 0.1. We have negative 0.11, even smaller. Now we go even smaller, 0.01. Right, you can see the pattern, right? Even smaller. You can see that the value is reaching 0, right? When you get closer to 0 from the left. So now it's 0.01. If you plug in 0.0001, you'll have even smaller number, which is very much closer to 0. So it's safe to say that the limit of x approaching 0 from the left is 0. You do the same thing for part B, which asks us to find the limit of fx approaching 0 from the right. So you do the same thing, but plug in the values reaching 0 but from the right. So I just go straight into 0.1. I have 0.09, then 0.01. It is smaller. It is even smaller. So it's safe to say that from the right as well, it is approaching 0. So when limit from the left and limit from the right is approaching the same number, it is a function. The limit exists and the value of the limit is 0. Okay. Now let us proceed to question 12. Question 12 asks us to solve the limit. So question 12a is limit x approach negative 3 x over x power of 3 plus 27, right? So for this one, how you can solve this? There are many ways how you can solve a limit, whether you draw the graph or you do just like the previous question, where you find the limit from the left and from the right and then see whether they are equal, or direct substitution or anything you have learned. But since we have tried the previous way, I think this is suitable if we did it like that. So limit x, we find limit x approach negative 3 from the left of this function, and limit x approach negative 3 from the right fx, which is what? So you need to plug in values of negative 3, but be sure for if the bottom part is negative, make them positive because of this modulus. Just the top part should be affected by negative value. Okay, so when you solve this, you'll get I'll not show you the calculation. You get negative infinity. This one is also negative infinity. So the limit x approach negative 3 of fx is negative infinity. Negative infinity means the limit does not exist, right? If I'm not mistaken. But this is just answering the question. So part B is very straightforward. Limit of x approach 27 of right, you just plug in the values. Just plug in the value inside the x, will get 1 over 9. Now part C. Part C is limit x approach 0 of tangent x over x So tangent x over x is 0 over 0, so it is undefined. But then let's try. Sorry. Tangent x is equal to sin x over cos x, right? So this is still, if you plug in straight away, it is still 0 over 0. So you need to use L'Hopital rule. L'Hopital rule is when you find the limit, but you differentiate the top and bottom part. So you differentiate sin x, you get cos x, and you differentiate x cos x, you get. You should know how to differentiate by now, right? So then you plug in 0, you get 1. This is your answer. Now the last part is D. Limit x approach 4 of 5 minus third of x plus 21 x minus 4. And this one is also straightforward. You plug in all the values and you will get by direct substitution, you get negative 1 over 10. So that's it for question 12. Now let's move on to question 13. Question 13 basically gives us fx equal to several functions at several different range of x. The first one is ax plus b at x more than 2, 4 at x equal to 2, x squared minus ab at x less than 2. So we have to compute the values of a and b so that the function is continuous. What you're gonna do is you equate all of these equations. Okay, so a continuous equation must be equal at the intersection, right? So what I mean is, so what you're going to do is you equate the limit of these three functions. Okay, so when the limits are all equal, thus the fx will be continuous. So limit ax plus b approaching x approaching 2 from the right equal to limit x approach 2 from the left of x squared minus ab equal to 4, right? Because 4 limit of x approaching 2 of 4 is still 4, right? So ax plus b is 2 positive because it is more than 2, x is 2 negative because the range is less than 2. So you solve this limit, and you equate everything, right? So we have learned this from the previous equation. Basically you'll get 2a plus b equal to 4 minus ab equal to 4. So we can separate this into two equations. Equal to 4 is the first equation, 4 minus ab equal to 4 is the second equation. So you solve this simultaneous equation and you get a equal to a equal to 2 and a equal to 0. Also there are two a values, so there will be two b value as well, right? So b is equal to 4 at a equal to 2 and b equal to 0. Sorry, b equal to 4 at a equal to 2 and b equal to b equal to 0 at a equal to 2 and b equal to 4 at a equal to 0. So there are 2 points, which is 2, 0 and 0, 4, where fx can be continuous. Okay, let us proceed with question 14. Question 14 asks us to find the limit of x approaching infinity of 2 minus cos x over 5x plus 1. Okay, you can do any methods you want, but sometimes it is hard when this is infinity or 0 and you have a trigo, right? So normally when you have question like this, you'll need to do the squeeze theorem, right? So refer to your squeeze theorem notes. Basically, in squeeze theorem there are things that you need to remember. For example, if it is trigo, a trigo must be less or equal than 1 and more or equal to negative 1. So this is a trigo. Cos x must be every trigo will have this more or equal than 1 and less than equal than 1 or more or equal than negative 1. So this is not something that I come up by myself, I just remember this. So we need to equate everything to this. So we have the base squeeze theorem here, but we need to make them equal to this. So you need to make sure that the middle part here is equal to this, right? And the left and right part should follow the same thing. So to get 2 minus cos x, we do 2 minus cos x, and the left and right side will have 2 minus, we just add 2 minus side, we already have cos x, 2 minus, so this will be 2 minus this one, and here you have 2 minus 1. Okay, next is the bottom part, so we add another 5x plus 1, so you have 2 minus 1 over 5x plus 1 and 2 minus 1 over. Okay, so this is our squeeze theorem. What you need to do is find the limit of this. Sorry, let me check first. Find the limit of this and the limit of this. Okay, so basically the limit of x, now we don't have trigo anymore, right? So negative of x approach infinity of 3 over 5x plus 1 is equal to 0, right? On the bottom is infinity, of course it will be 0. 5x plus 5 infinity plus 1 is infinity, right? So 3 over infinity must be 0, and limit, sorry, I'll put it here, this one is here, this one is here, limit x approach infinity of 1 over 5x plus 1 is also 0, right? So limit, these two limits are equal, they are equal, so the limit of x approach infinity of 2 minus cos x over 5x plus 1 is equal to 0. So this is your answer. If they are not equal, then the limit does not exist. Now let's proceed with question 15. Question 15 asks us to compute limit, but limit is given in conditional terms as well, where the value of x is different, but this is pretty much similar to what we've done, except that you need to know which function you should use. We have 4 cos x at x less or equal than 0, 5x when x more than 0 and less or equal than 5, and x power of 3 over 5 when x is more than 2. So part A, it asks us to find the limit of x approach to from the left of gx. So 2 from the left, which function should you use? 2 from the left must be this one, right? Because 2 is within this range. So of 5x, and you'll get your answer. If I'm not mistaken, it will be 10, right? So part B, try yourself. Limit of x approaching to positive. So to positive is where? To positive is also here. So 5x as well, 10 as well. Okay, so C asks us to find limit x approach 0. 0 is here, right? Less or equal than 0. So 4 cos x, and we'll get, basically the limit does not exist here, because if you find limit x approach negative of this is not equal to limit of x approach 0 positive of 4 cos x, so it is not exist. Actually, for all you can, of course the previous one already have negative and positive, so but the third one, it asks us directly approach 0 only, so it's better if you calculate from the left and from the right and see whether the limit exists. You need to find first whether the limit exists or not, and the last part is limit x approach 5, the same like this. It is approach 5, not positive or negative. So what 5 is this one, right? X more than 2, 5 must be within this range, so x power of 3 over 5. But this can be solved by direct substitution, but of course you can still find like this from the left and from the right, you get the same answer, but this time you get 25. Okay, that's it. We are on to the final question. Okay, it's question 16. Question 16 asks us to determine the continuity of the given function, and this is the given function: 5 power of 5x over x squared minus 1 at x equal to plus minus 1. Okay, so how do you solve this? This is pretty simple. Actually, we need to determine the continuity of this at x plus minus 1. Basically, you need to solve it 2 times. First is at x equal to 1, and the second time is at x equal to negative 1. So at x equal to 1, you find the limit approaching x equal to 1 of this function. So limit, you need to find from the left first, limit of x approach 1 positive of fx, then limit of x approach 1 negative of fx. So find this by yourself. You will get 0 you get infinity here and 0 here. So from the right is not equal to from the left, so limit does not exist. Limit does not exist, which means discontinuity at x equal to 1. We repeat the same thing, but at x equal to -1, at x equal to -1, limit x approach -1 from the right of fx, limit x approach -1 from the left of fx, and we get infinity and 0 as well. So it is also discontinuous at x equal to -1. So that's all for this tutorial. Thank you for watching. If you made it till the end of the video, we'll meet again in chapter 2. Thank you.